Hello, everyone. Thank you for having me here. I'm Mike. As Robert mentioned, I'm a senior DevSecOps engineer, SecOps engineer at Fullstacks, mainly dealing with Vault. We heard today from Marcel a couple of times, Vault. And yeah, today I will be kind of talking about it a bit, like the integration with Securosys HSM and how it plays out for our customers. Before I get into some technical issues. Almost. Yes. Before I get into it, a quick introduction to who we are and what we do. We are quite newly founded, like in 2020. Two owners, engineers themselves, come from like a banking data center sort of field. Quite fast growing. That picture was taken last year in Vienna. I think nowadays we are double the size. Some of you might recognize that I'm not on there because I joined after that. Yeah, we have quite of a track record, and some names are quite big, quite heavily in the financing sector, as yeah, most of our engineers come from that sort of field. So our expertise kind of lies in that sector. What do we sort of do? Essentially, we deal with like the cloud native environment, anything that sort of revolves around cloud environments and Kubernetes. You might recognize we are quite heavily using HashiCorp products. Like we basically try to automate everything we do using Terraform and Ansible at the same time. Yeah, Vault for like secrets management, Console for API gateways or service meshes. And yeah, also like for our Kubernetes distributions, we use mainly SUSE products with RKE2 and NeuVector for security. And also like newly, we have a dedicated Splunk team, consulting also in that sort of field. Let's go further. This is more like for show purposes, as I always call it. We are sort of a small team, like medium-sized team. So we try to also like do sort of certifications. For me, like real life experience or like on the field is more worth than any certification. But yeah, it always looks good when you sort of have the certifications. So yeah, but that's more like from an engineer's perspective. So what is HashiCorp Vault? We heard it today a couple of times. I feel like whenever I ask customers that sort of want Vault, I always get some random answers that are partly true, partly not true. The best one was to compare to products like Bitwarden. I sort of guess could somehow do it, but it's not necessarily the use case for it. I consider Vault more like a secrets management system, a centralized management system. And it does have a couple of use cases, which I will get into it in the next slide. But on the right side, you sort of see like a workflow on how Vault works. And I guess the key takeaway from that is that every request is authenticated and authorized within Vault. It can function as identity broker. On an honest level, I've not seen it yet being used in that sense. Yeah. So I've sort of just listed a couple of secret engines and auth engines. I will get into that in a second, what that means. There's more to that, but given the limited time I have, I just picked out a couple of relevant topics. So a secret engine is essentially a functionality that Vault provides. The most commonly and fundamental thing that I see at customers is a key value like store engine to store like your passwords, API keys, certificates, configurations, you name it. Essentially anything that is confidential and that you want to store. There's two versions of it. The version 1 is basically, it's not versioned. So if you update it, the newest version is the only one that's available. The second version has metadata associated to it, so you can update it to newer versions, but you can also access older versions, and there's like a soft delete feature in place as well. It can function as a certificate authority, or like you can build your PKI with it. quite heavily used as well nowadays, especially with like Cert Manager in Kubernetes environments to provide certificates to like your services. SSH engine, sort of commonly also used. It's essentially generates short-lived SSH credentials for clients that need it. So there's like no long-lived SSH certificates. It can also sign keys if you need it. Transit, it gets more interesting. It provides encryption as a service without storing the data. I have some sort of example towards that later on, like a small demo, so to speak. LDAP, similar to SSH, it essentially can create short-lived LDAP like users for you if necessary. Transform is also an encryption as a service in a sense, but it's more focused on like format preserving encryption, tokenization, and masking. It also has, nowadays that cloud providers are quite on the go, provides or like has the ability to create IAM credentials and service accounts for you, also short-lived, can be revoked if necessary before or not. And databases, it can create short-lived users for your applications and revoke them once the access is essentially finished. So that's all and good, but how would you sort of authenticate, or like what are the ways to authenticate to Vault in the first place? That would be done with like a couple of like LDAP, that's more like for users that might log into Vault through the UI. Kubernetes service accounts can be used. You can use like JOT tokens also to authenticate, or like any sort of like, Google like cloud providers. April is a systematic way to provide it. It's more like for legacy systems to sort of like Kubernetes service accounts to access in the name of the application. Or simply TLS certificates you can use, but I've not really necessarily seen that yet. So now that we've seen it, how would the access to Vault look like from a more technical perspective? Essentially, Vault has an API you can like talk to, whether that's through the UI, CLI, or like directly to the API. After that, you need to identify yourself. That's done through a couple of different ways that I mentioned just previously in the previous slide. There's a couple of more that you might realize. Then you need a policy. So let's say you have authenticated yourself, then you need to be authorized. Everything in Vault is denied by default. And policies come into play here, essentially, yes, what can I do with it, where can I access, and what can I not do? Everything that you do at that point is also audited. And once you basically have your token, you can basically access the services that Vault provides or are configured for your use. So let's pretend you have just deployed a Vault instance. It doesn't work, let me just say it like that, because it is in the sealed state. The sealed state means everything in Vault is encrypted, but Vault does not yet have the means to decrypt the data it needs. So how does the unsealing of Vault work? Essentially, in order to decrypt whatever is in the storage backend, you need the encryption key. However, the encryption key is encrypted with a master key. And the master key is essentially like stored either in like Shamir key shares, that's people that know about it, it's basically shards of your key that you sort of need to create the master key. Or the better solution is either to use a cloud KMS or in our case, HSM, dedicated HSM, that handles the creation of the master key for you. I have to note the Shamir key shares, essentially how it works. Let's say you get like 5 key shares, and to unseal Vault, let's say you need 3. In the realist sense, it's recommended that those key shares are shared to other people, or like every person, let's say, has just 1 key share. But in reality, I can tell you they download the JSON file and just save it on their local file system, and that we have also seen it that it was pushed to Git. So that does not really work, to be honest. So a HSM or a cloud KMS takes that away from you, takes the burden away, and let's say makes the whole thing a bit more safe. After that unsealing process, Vault can access whatever engines, policies you need, and is fully functional. And another benefit you get with a cloud HSM like Securosys is that the unsealing is done automatically. If not, you need to do it manually for every node of the vault. So essentially, if it restarts, you have to do the vault procedure again. It's a pain, to be honest. Automating that is also not very easy and quite difficult to do it in a secure way. So systems like Securosys HSM take that burden away from your operations team as well. Another feature that you get with a HSM integration is seal wrapping, as Vault calls it. Once you do that, essentially, I call it like double encryption. So information is double encrypted with the HSM. There's one thing that comes with that. Normally, if you don't have that, the only time that Vault connects to the HSM is when it needs to unseal or regenerate the root key, but that's not necessarily important. However, once the seal wrapping is activated, you pretty much need a permanent connection to the cloud HSM. So today I wanted to talk about, or like give a demonstration about a customer we have. It's Grenke AG. Some of you might know it. It's an enterprise leasing company. I think it has over 2,000 employees, over 800 million revenue last year, kind of thing. And they have 3 Vault instances. It's very simplified, all secured with Securosys HSM. And they mainly are migrating currently to Kubernetes and also kind of Azure, like finance. Let's say companies are quite wary of cloud, so it's more like a POC in that sense. And obviously, for people that know how Vault works, let's say you have set up Vault. That's the first hurdle. The second one comes, how do you build Vault internally for it to be securely consumed? This is sort of like not necessarily what the customer has, but was something that we presented to the customer. We didn't go necessarily with it, but the others didn't actually fit in there properly. So it's a simplified version. Every blue square that you see there is a Vault namespace. To quickly tell what it is, a Vault namespace is sort of like a Vault within Vault. Let's say department B here is not really aware of department A. It thinks it's its own Vault cluster in that sense. And that's sort of how you can have multi-tenant consumers in a way. And within those namespaces, you have those secret engines, as previously called a key value engine. And then you might have your paths where you store your app credentials, CI/CD tokens, JOT tokens, whatsoever. Then there's like certain ways to access it. LDAP auth that I mentioned is more like for users. We configure that in the root namespace that already exists when you deploy Vault. The reason for that is there is actually a way for you to like log in the root namespace and traverse to like sub namespaces in that sense through internal and external groups. So essentially, you would map an external LDAP group into internal Vault groups. Otherwise, if we don't do that there, we would need to configure that auth engine at every namespace individually. And that's quite a bit of a burden to manage and whatsoever. However, services, automated services, are usually just created straight at the end namespace where they might consume as secret engines. And you can also bind policies, what is available, what at every namespace, because those are not like traversed through the individual namespaces. A feature that they're also using was with the introduction of Kubernetes, PKI. How do we give our services a way to get certificates? And how it kind of works, and also how Vault or HashiCorp recommends, is to have the root CA outside of Vault, which is most of the time the companies already have a PKI existing. We create a CSR that import that into Vault. That in that case, depending on the needs, we create a sub issuing CA, like in that comes CA2, which then signs a certificate that's requested by a client. How that looks more a bit in the technical ways can be sort of seen here. As I mentioned, we create a CSR that's being signed, we import it, And already at the importing, that's not super policies, but that's already based on the PKI secrets engine. You can already like set certain layers of like protection, like what domains are allowed. And like how many subdomains, blob domains, whatever you want to do. That can be further enhanced with policies, what's allowed, like depending on the client that's requesting it. And essentially, the end goal is for a client to request a certificate. What's not on here, I could actually not fit it on there, to be honest, is the cert manager integration. So as an end user perspective, or as a developer perspective, there is no need for you to do anything, as we can automate that process already for you. So you essentially just deploy your application, and that's it. The demo I was going to show you, I can super use like the customer infrastructure for that. So I quickly deployed, I call it like a sandbox in Exascale Cloud. Some of you might already know it. It's a Swiss-based cloud provider we work with as well. Essentially, how we deploy Vault is with Terraform, with combination of Ansible. So Terraform does the provisioning of the VMs, the keys that are needed, security group for ingress and egress rules. And Ansible does sort of like, the magic to create all the necessary folders that Vault needs. The files performs like a couple of checks if like Vault can be installed there and would be functional, and also takes the configuration for the Securosys Cloud HSM. For people that already done that, it's actually not that difficult. I think it's just a couple of lines. The just works. And then I have also like, once it's deployed, I have like a downstream RKE cluster where I have a couple of demos. And if someone has deployed Vault, they know to provision Vault and update it in an automatic way can be quite challenging, to be honest. And we have sort of like done the work in that sense, and that's sort of all the code you need to provision a fully HA with Securosys HSM Vault. And also updating is also the same. You just change the versions, deploy it, and it provisions new VMs, does the migration, and basically decommissions the old ones. So the first demo or like feature I would like to talk about, because I talked a lot about Kubernetes as well in that sense, was the Vault Secrets operator. It essentially syncs secrets from Vault into your Kubernetes cluster so applications can use it. A couple of features that it has: it can auto-detect and fix secret drift. It can take over existing secrets. Sounds weird, but it's more like for migration purposes. If you have applications that already have secrets they consume and you sort of want to give that basically to Vault. And it can also restart applications on a secret change and support for secret data transformation, which is essentially, let's say, craft you like a PostgreSQL SQL URL for you, given like on annotations or labels that your applications might have. On the left side is a very simple demonstration. You have the controller, essentially it's a deployment that handles the connection to Vault. It will then create your secret, and your application is just essentially consuming the secret. This is a bit more technical demonstration or like a slide. Essentially what I mentioned on the right side, you have the Vault Secrets operator. Then you could have several Vault instances. They're essentially, I just displayed them as connection A and B, depending on what you want. And where it gets more interesting is in this Vault authentication in the middle here, which sort of like references the Vault connection you want or the Vault address, and also role. On the role, you have the policy bound, which sort of tells what can I do and what can I not do. As you can kind of see on the top right, there's an example role. Essentially, under this key value engine, I can read anything that comes after it. And that will create, at the end of the day, our secret. So how do we go on with syncing an existing secret in Vault into Kubernetes? Let's say I have this sort of configuration, a very basic example. I would deploy this resource. Is called a Vault static secret. The path within Vault would be key value 2 web app config, as essentially everything within Vault is path-based. We would also reference that in our Vault static secret, and that would essentially create us our secret that can be consumed. The next example is what I said, migrating existing secrets into Vault. Same principle, the secret already exists. We would create again the static secret and essentially just add override true, and this would change the password and give basically control to the Vault secrets operator. So at that point, it basically manages it. Rolling out new updated secrets, that's actually quite a topic. Who is, if someone has administered Kubernetes and Teams knows, it's actually not always that easy to automatically roll out applications on a secret change. There is individual controllers like Reloader, I think it's called. So let's say we have this sort of Nginx demo that has those environment variables for the username and password, and they might look like that. Once we have also our Vault static secret, we just reference the deployment and like the name, like essentially the reference to it. Once we have done that, the secrets operator will recognize if there's a change in the secret and will automatically restart your application for you. This has integrations with Argo rollouts, as that's more commonly used to roll out new releases. And yeah, that's how you essentially could do it. It's more for the use case if applications can't like necessarily recognize a change in terms of the secrets they're consuming. So that's more of a way to make it like an easier for the developers. Another feature that's kind of on the coming is to use Vault, or like the idea of Vault is to use it as a centralized secrets management. So essentially all your secrets, whatever your company consumes, are stored in Vault, and then you distribute them from that point on. And obviously with the coming of the cloud providers, it's quite a big thing, and they have their own like vaults or like secret storages. And Vault allows you to essentially distribute your existing secrets in Vault to those key stores. So if you have VMs or applications deployed in the cloud providers, that they can use the native API to consume those secrets. How would that work? Essentially, you configure an access to like a destination. I have used in my demo at the Azure Key Vault. Then I can select, that's like in the UI, you would normally do this more like in an automated way, but for demonstration purposes, I select my secret. Basically sync it, I think it takes 2 or 3 seconds once that's sort of done, at least that's sort of what you see in the UI. It would say synced, and it would also be at that point available in the Azure Key Vault. That also works the other way, so if I update it, it would automatically recognize, do that, and if I delete the secret, let's say in Azure Key Vault, it would recreate it. However, if I delete the secret in Vault, it would also delete the secret in Azure Key Vault. Another cool feature I would like to sort of quickly talk about is the transform engine. I mentioned previously I come from a data center where I was managing Kubernetes platforms and Vault. It's more of a trivial example, but I would quite quickly see, we had Splunk in use, and I would quickly, or like quite often see card numbers or like transaction IDs, whatever you call it, in the logs in Splunk, which always sort of bothered me at the same time, didn't. But Vault, as I mentioned previously, offers like encryption as a service. So technically you could encrypt like sensitive data like card numbers without storing them, and when they're like needed, your application would essentially talk back to Vault to decrypt the value and actually get the actual card number back. Even though I have to mention such functionality is, I think, already provided by most of those logging systems as well, that when they recognize that they do it for you. That's something I actually stole from the Vault documentation that sort of explains the Vault principle. So you have this sort of plain text, Vault encodes that value, your application stores the encoded value, and when it's needed, it will essentially retrieve or like decode the actual value from Vault. The benefit from that is quite obvious. If you have a security breach, they will only have the encoded values, which are pretty much useless in that sense. So it's just an additional layer of security. This is another example, it's more like in the masking sense for my personal information. So you can mask like phone numbers, passports, whatever you call it. That's sort of how you would do it. There's like essentially just a simple regex. Alphabet, that's a built-in way. It's essentially just for numerics. But you can also define your own that only certain characters are allowed. Yeah, just like so for as a quick understanding.